Hello there, Mr. Vessel here today, and what we're going to look at is an example from an AP Stats exam from 2019. This was the first question, and often in the first question there's a display to analyze, and sometimes it's going to ask to do a description of that display. So this one is that kind of question, so let's dive in here. What you'll see kind of right away, we get this relatively quick write-up. Basically, you get the sizes in square feet of 20 rooms in a student residence hall at a certain university are summarized in the following histogram. And it asks us to, based on the histogram, write a few sentences describing the distribution. And when we see this describe the distribution, this phrasing, a lot of things come to mind for me. Basically, I want to write about the shape. I want to talk about outliers. I want to talk about center and spread. And this is where sometimes using a SHOCKS acronym comes in handy here. So whenever we describe or even compare distributions, these are the four things that we want to mention. And I think in this particular case, histograms can be easy to see shape. Shape's great and it's really quick, and you can even get a really quick sense for outliers. Sometimes center and spread can be more challenging in a histogram because you don't get specific numbers to work with, and you're going to need to be more vague with your responses if you like to use values for these. So let's start with shape here. It's really important to mention that there are definitely, it's bimodal. You've got these two clusters. You could also notice this gap here, this very in the center of this display. There's only one dorm room that's between 200 and 250. So for shape, what I want to mention is the bimodalness. So the shape of, and I got to do this in context, of course, too. But the shape of the distribution of room sizes, this is getting it in context here, is bimodal with a gap between 200 and 250 square feet. We could even mention like where these clusters are located. The clusters are between 150 and 200 square feet, and 250 to 300. So we want to basically describe where these two clusters are, or where that lack of data is when we're talking about shape here. This is a full credit response in that I've given maybe too much information, honestly. We've got the two clusters, we've got the gap, and really just one of those two is usually sufficient. But what's definitely important is we want to avoid just saying it's symmetric. What the goal of these tasks are is that if you only had these sentences to go off of, that you'd get a pretty clear picture of what the display must have looked like. So this has that feature here where we got the clusters, we got where the gap of the data is, and the next thing I want to mention, and it turned out this wasn't even scored for this particular question, the outliers. There don't appear to be any outliers. And that's all I want to mention here. I'm not going to go through and calculate it, especially with a histogram. It's not possible to get some specific numbers here. So we're just going to mention it. And a lot of the time this isn't even scored on an AP question, and this one was no different, but it's still safe to mention it, that there do not appear to be any outliers. And where these histograms can often get a little tricky are center and spread, because of the fact that you just don't have as much information as you might like. Now, it's okay to be vague, but when I do have histograms, if I can kind of locate where the median is, I think that's a really good strategy. And the median is going to be that center data point. It told us there were 20 rooms in this sample, so what we want to find is like where's that 10th and 11th room, and that will help us find out where the median is. And if we sort of count from the left, notice there's 3 here, there's 6 here, so we're to 9. Here's our 10th dorm room. So the next one's going to have, there's 7 in here, there's 3 here. So it's kind of splitting up in halves right here, We got 10 numbers on the left side of this, 10 numbers on the right side. But we don't know what the median actually is. We just know it would be an average of whatever the data point is that's here. Again, I don't know what that number is. I just know it's somewhere between 200 and 250, and whatever the lowest number is in this column between 250 and 300. So I don't know what the specific median is, but it's okay. We don't need to give a specific number. We just want to be able to say, well, the median is somewhere, and I guess technically it could be anywhere between 200 and 300 feet. It's likely to be more in the 200 to 250, and we'll see it actually is between 200 and 250. But because I don't know where these 7 numbers are, there's a good chance it's on the lower end here, but I don't know that for sure. But the median is somewhere in this region. The median is somewhere between 200 and 250 square feet. And similarly for range, I can't be too specific with the range as well, because I've got these 3 numbers out here for the maximum. Don't know what it is. 3 numbers for the minimum. It's somewhere between 100 and 150, but it's okay. We don't need it. What we want to be able to say is, the range at most, it could be 250 feet if I had the 350 max and the 100 minimum. It's also possible that it's much less than that. It could be 150 if I've got a bunch of numbers here, 300, and a bunch of numbers in this column that's close to 150. So we're just going to state that for the range is somewhere between here to here and here to here. And that'll take care of spread in this case. So we'll use range. It's just a little quicker than standard deviation. We'd totally be guessing with that one. And same with the IQR. We know what the IQR, you could use something similar with that. It's possible to do that. I think the range is just a little bit quicker here. And it's okay to be vague here. We just want to mention somewhere between 250 and 150 square feet. And that covers everything we need to be able to do when you're describing the distribution. It's got all the basics, the shape, the outliers, the center, and the spread. And that's all we need to make sure we do for part A. And sorry about the spacing for this one, but part B says summary statistics are given. And one thing I'd want to point out, when we were taking this exam, AP exams are very literal, and if it says based on the histogram, you should base your answers on the histogram. You shouldn't use the values in the summary statistics here, so we wouldn't want to say the median is 253.5. Oh, never mind. I actually have a little mistake to fix. When I said earlier the median is somewhere between 200 and 300, notice I wrote 200 and 250, somewhere between 200 and 300, and that's again because the 10th and 11th data point falls somewhere in these 2 bins, but I don't know exactly which bin it falls between, so I gotta say the median somewhere between 200 and 300. It turns out it's 253, but again, we don't use this number in part A. We don't even need this number. It says based on the histogram. So based on the histogram, I wouldn't know that the median is 253.5. What they're asking us to do with part B is actually determine if there are any outliers and then make a box plot. So it doesn't tell us which method to use for outliers. It looks like it's up to us, but because we're making a box plot, I think it'd probably be smarter to use the 1.5 method here, 1.5 times the IQR method for outliers. And just as a reminder for that, there are 2 cutoff points. The first cutoff point, the lower bound, is going to be Q1, subtracting off that 1.5 IQR. And the upper bound is Q3 plus 1.5 IQRs. And now I'm going to show the visual here first. I'm actually going to make the box plot and sort of talk about why there can't be outliers just using the image of the box plot. So, and this particular set of data, we have the 5-number summary here. And I'm going to start with the box part for a second here. So 174 is where Q1 is. Let's be about here. And then the median's at 253.5. Let's be about here. Q3 is up to 292, almost to 300 there. So here's our box. And I'm not going to draw this out just yet. So the maximum is 315, but what I wanted to point out is like when you do calculate outliers with a box plot, what the visual representation of that is you use this width of the box to determine whether or not there's extreme numbers or not. And how you do that, you take this IQR, and remember the IQR is just the distance between Q3 and Q1. And what we do with that distance, I'm going to draw this up here. So this is a little bonus for this particular task, but the IQR is just the length of the box. And then this 1.5 multiplier, all it does is makes this box a little bit bigger, so it gives us a box that's 50% larger than the IQR. And what we're going to do with that number, we're going to take Q3 and add it on, and we're going to take Q1 and subtract that number away. And if you could just kind of imagine like taking this distance, making it 50% bigger, and then adding it on to Q3 and subtracting it off from Q1, we're way off the grid here for outlier calculations. And there's no way you're going to get outliers if the maximum is only right here at 315. And then the minimum is only 134, about here. So there's no way there are going to be outliers for this particular box plot, because that box is way longer than what you'd necessarily need. That cutoff point is going to be way out here, and if you'd like to get that cutoff point, it's just 292 plus 1.5 times 292 minus 174. And similarly, and calculate the lower bound that way too. These two numbers are way below, well, not two numbers, the lower bound is way below what would be necessary. It's a -3 even. Clearly no number is lower than -3. And then to check the upper bound, 469, so it's way higher than the maximum. So there are no outliers. And again, you can double check that with the calculations. You could use the visual of a box plot to sort of see that there couldn't be outliers with this as well. So then the final task, and this is fairly common for AP questions, if you have to make a display, they usually want to know why did you make this display. So the follow-up question has to do with this box plot that's just created. It says what characteristic of the shape of the distribution of room size is apparent from the histogram, but not in the box plot. You know, if you put this box plot on the same grid from above, you can get the same information in terms of like the 5-number summary, but it's very different visually, and the shape is really difficult to infer from a box plot. There's no way to know that there's only one number between 200 and 250 from the box plot. It's only one data point in here, and that's just difficult to see from a box plot. So the characteristic of shape that you can see in the histogram but not in the box plot would have to be the bimodal nature. So the histogram shows the shape as bimodal, whereas you cannot see this in the box plot. And it's really important to make sure that you mention like what you can see and what you can't see in the other one to get full credit for these responses, just to be safe, so that the histogram shows that bimodalness but the box plot does not. And that's all it would take for full credit on this particular response. So thanks for checking this one out. This was the 2019 number 1, and have a good day.